Today we are discussing the 12th level chapter, and the chapter name is differential equations. In this video we are discussing the many more types of formations and solution and example. And in formation sections we are discussing 1, 2, 3, 4, 5 types of formations, and solution sections we are discussing general, particular and singular. And third we are discussing the example, and this is the geometricals, this is the physical, this is the chemical, this is the biological, and the economics or economicals. These types of formations for the differential equation is there. And solution, these three, that is a general, particular and singular, and the example. Now at first we are discussing the formations. In this section at first we are discussing this, the geometrical formation, then physical, then chemical, then biological, then economical or economics. That is 1, 2, 3, 4, 5. These are 1, 2, 3, 4, 5 types of formation we are discussing at first, one by one. Now 5 types of formations of differential equation is there. First is geometrics or geometricals. In this part, differential equation will be that types, and this is x square plus y square is equal to c square is the equation, given equation of geometrical equations, and they are geometric differential equation. Differential equation for the geometrical equations of this is, if we derivative this, then we get this one, and after calculating we get this one. So this is the geometrical or geometric differential equation of the given equations. Now we move to the next part, that is the physicals. Physical, that is a v is equal to dv dx is equal to minus of mu x to the power minus 3, whereas x is a displacement and v is a velocity. So the differential equation of physical will be that types differential equations. Now chemical differential equation will be that type, that is the dx by dt is equal to k times of 100 minus x, whereas k is a constant, t is a times, and x is a quantity. And now the biological differential equation will be that type, that is dx by dt is equal to k times of root under x, whereas k is a constant, t is a times, and x is a quantity of germs, quantity of some things in related to biology. And now economics and economical differential equation will be that types, when x is a number of workers, number of laborers, number of something deals with economics, and this is the total revenue or total income. Then the equation, differential equation of economics or economical will be dr by dx is equal to 2 divided by x plus 1 to the power 3 plus of 3. So this is the complete of formation sections, and we are discussing 1, 2, 3, 4, 5 types of formations and their standard differential equations. Now we move to the next part, that is the solution sections. Now we are discussing about the solution of the differential equations. Now the general solutions, suppose the equation is equal to y is equal to a sin x plus b cos x, whereas a and b are the constant. Then after differentiating with respect to x, we get dy by dx is equal to a derivative of sin is equal to cos, and derivative of cos is equal to minus of sin, and repeatedly we have derivative second times, that is a d2y dx square is equal to minus a sin x. Why sin x? Because the derivative of cos x is equal to minus of sin x. And similarly b is there and minus is there, and the derivative of sin x is equal to cos x. This is the minus of y. So we are putting this is the minus of y. So d2y dx square is equal to minus of y is a general solution of the given equation this. And now in the particular solution section, if we put the value of a and the value of b as a 1 and 2, then we get y is equal to sin x plus 2 cos x. Now after calculating similarly these types and putting the value of a and b 1 and 2, we get d2y dx square is equal to minus of y, similarly as the above. Now in the singular solution section, that is, if we take the equation y is equal to x into dy dx plus a by dy dx, whereas a is a constant. Now putting dy dx as an p, we get dp dx times of x minus a by p square is equal to 0 after calculating and putting dy dx is equal to p in these equations. That is, this will be 0 or that will be 0. If this will be 0, then we get dp dx is equal to 0. If this will be 0, then we get x is equal to a by p square. Now replacing x as a by p square, we get y square is equal to 4ax after calculating and putting x is equal to a by p square. So this is the singular solution of the given equation y is equal to x into dy dx plus a divided by dy dx. This is the complete of solution sections. There is a general solution is this type, particular solution is this type, and singular solution is that types. For the equation of this one, this is the singular solution. For the equation of this one, this is the particular solution. For the equation of this one, this is the general solutions. Now we move to the next part, that is the example section of differential equation. Now we are discussing the first example of the day. Find the order and degree of the given differential equations. Now at first we are discussing what is the order. Order means how many times of differentiation is there. There are 2 times repetition of the derivatives or differentiation is there. So the order will be 2. That is first time. And now second time derivative. So order will be 2. That is, for the given differential equation, order will be the how many types of derivative or differentiation present in the given differential equations. Now next part, there is a degree. Degree means the power of highest differentiations. So here we can see this will be the considered as an 1. So degree will be 1. That is, for the given differential equation, the order is 2 and the degree is 1. This is important for the joint level student as well as the board exam student. So order and degree is a important concept for the short type questions. The second example of the day is find the differential equation of these equations. So y is equal to a times of e to the power x plus b times of e to the power minus x. Now derivatives with respect to x we get, that is the dy dx is equal to a into the derivative of e to the power x is equal to e to the power x, and similarly the derivative of e to the power minus x will be minus e to the power x. Now next time again with derivatives, we get, that is a dy dx is equal to a, and we know that the derivative of e to the power x is equal to e to the power x, and similarly minus is there, and the derivative of e to the power minus x is equal to minus of e to the power x. Now simplifying this we get, which is the y. So d2y dx square is equal to y. Now the order is equal to because 2 times derivative is there and the degree is a 1 because the power of this is equal to 1. Now we are discussing the last and the final example of the day. The last and the final example of the day is show that d2y by dr square plus of 2r du d by dr is equal to 0 is a differential equations of u is equal to a by r plus of b, whereas a and b are the constant. Now in solution part, u is equal to a by r plus of b. Differentiating with respect to r, we get du by dr is equal to minus a by r square, and this is a 0 because the derivative of constant part, that is a b part, will be the 0. Now second time derivative we get, and this will be the minus, and similarly a by how we get this, r to the power minus 2 derivative will be r to the power this one. So minus 2 by r cube is multiplied with this one, then we get minus and minus will be plus, and 2 multiplied with a is a 2a, and r cube is there. Now plus 2 by r du dr now putting the value of this one and that one, that is 2a by r cube and plus 2r, and putting value of this minus a by r square, that is 2a by r cube minus 2a by r cube. This will be 0. So this is d2y by dr square plus 2 by r du by dr is equal to 0 is a differential equation of the given this part, which is proved. This is the complete of the example sections. Hope today's discussions about the differential equations and the information we are discussing with you increase your knowledge, and when you practicing this chapter in future, this video help you to understand this chapter and help you to solve these types of questions in your board exam as well as the competitive exams.